Last spring, you guys learned about the unit circle. I'm going to go ahead and refresh your memory on what the unit circle is and what are all the different important values we need. So the unit circle is literally a circle centered at the origin whose radius is 1. So when we're going back and filling in the coordinates, this is what I want you to picture, even though we don't necessarily draw it on the axes. The first thing that we're going to put on the unit circle are the angle measurements. So everything starts from the positive x-axis. So this is going to be 0 degrees, which makes this 90 degrees, which makes this 180. This down here is 270. Back around makes this 360 degrees. The ones in between are just angles that we frequently use in trig and other places. The first ones I'm going to label are the ones right in the middle. So between 0 and 90, halfway is going to be 45 degrees. So each of these middle ones are 45 degrees. So we've got 90 plus 45 is 135. 180 plus 45 is 225. 270 plus 45 is 315 degrees. Okay, the ones left over, if we look here, this is split up into 3 equal pieces. So this is 1/3 of 90, which is 30. So we're just going to count around the circle by 30 degrees. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. The next thing we put on the unit circle are the radian equivalents. So radians technically are an arc length. So it's how far around this circle we are. Well, arc length, if we think about the whole circle, would be the circumference. So the circumference is 2 pi r. So if the radius is 1, then the distance all the way around this circle is 2 pi radians. So this is 0 radians. It is also 2 pi radians, which makes halfway around the circle pi radians. Then we're going to fill in the quadrantals. So the quadrantals are the top and the bottom and the sides. So if this is pi, this would be half of that, which we will call pi over 2, which makes this here 1.5, or 3 pi over 2. So those are the quadrantals. I'm going to then do all the 45s. So if this is half of pi over 2, that would be 1/4 pi, or pi over 4, which makes this 2 pi over 4, which makes this 3 pi over 4. This would be 4 pi over 4. This is 5 pi over 4, 6 pi over 4, 7 pi over 4. Then we're going to go into the 30-degree ones. So looking at the top half of the circle here, the top half of the circle is pi. And I have 1, 2, 3, 4, 5, 6 equal slices, ignoring the 45s here. So each of the 30s are pi over 6. So this distance here is pi over 6. This is 2 pi over 6, which we can reduce to 1 pi over 3. This is 3 pi over 6, 4 pi over 6, which is going to be 2 pi over 3, 5 pi over 6, 6 pi over 6. This is 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6, 10 pi over 6, which is equal to 5 pi over 3, 11 pi over 6, which would bring us back to 12 pi over 6, which is equal to 2 pi. So those are the angles in degrees and radians. The next thing what we're going to do is fill in the coordinates. And again, this is the origin. This distance is 1, which means this has an x value of 1 and a y value of 0. Straight up, this is going to have an x value of 0 and a y value of 1. This is going to have an x value of -1, a y value of 0. This is going to be 0, -1. Okay, now we're going to fill in the rest of these coordinates. I'm going to start with the 45s. Okay, so if you remember special right triangles, so what we have is a 45-degree angle, an x value, and a y value that we are trying to find. If this is their perpendicular, makes that 45. The radius of the circle is 1, which makes the hypotenuse 1. Well, if these two angles are the same, the x and the y values are going to end up being the same here. So what I can do is the Pythagorean theorem. So I'm going to say x squared plus x squared equals 1 squared. So 2x squared equals 1. So x squared equals 1/2. So x is going to equal the square root of 1/2. Okay, which is equal to 1 over root 2, which when we rationalize that is root 2 over 2. So both of these lengths are root 2 over 2. Back to the unit circle. That means this x distance is root 2 over 2, and this y distance is root 2 over 2. So the coordinates here are root 2 over 2 over root 2 over 2. All four of the angles that correspond to the 45 are going to have those same coordinates. So that's going to be 45, 135, 225, and 315, because they're going to have the same x distance and y distance, it's just they're going to be in different quadrants, so we need to match that. So this is going to have a negative x value of root 2 over 2, a positive y value. Down here they're both going to be negative. Here we have a positive x and a negative y. Okay, next we're going to look at this triangle. Here, we have a 30-degree angle here. We're trying to find the x and the y that fill this in. If this is 30, that makes this angle 60, and the radius of our circle is still going to be 1. I'm going to derive this one, and again, you may remember this from Algebra 2. What I'm going to do is I'm going to mirror this over. So this is going to be 60, this is going to be 30. Well, this angle is 60, this combined angle is 60, this angle is 60. So this outside circle, or outside triangle, is an equilateral triangle. So if this is 1, this is 1, and this is 1. Well, by that logic, that means my y is going to be 1/2. Okay, now I'm going to take away the extra stuff and go back to my original triangle here. Now I have two sides of this triangle. I have this side is 1/2 because it's half of the equilateral triangle, and this is 1. So x squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 equals 1. X squared is going to equal 3/4. If I take that square root, that's going to be the square root of 3 over the square root of 4, which is 2. So this distance is root 3 over 2. So filling that in, the x distance here is root 3 over 2. The y distance is 1/2, and it should make sense just even looking at it that this distance is bigger than this distance. Root 3 is bigger than 1, so root 3 over 2 is bigger than 1/2. So all of the angles that have that same proportion, which is going to be that angle, that angle, that angle, and that angle, they have the same x and y values, just changed for the different quadrants. So this one's a negative root 3 over 2, 1/2. This is a negative root 3 over 2, negative 1/2. This is a positive root 3 over 2, negative 1/2. Going back to my triangles, we figured that on the 30, opposite the 30 was 1/2, opposite the 60 was root 3 over 2. Well, the 60 degrees is going to be that same triangle, just flipped around, where this side is going to be root 3 over 2, and this side is going to be 1/2. The short is 1/2, the long is root 3 over 2. So our remaining angles are all of our 60s. But again, just geometrically, they're going to have the same x and y values because they're the same distance. So this is going to have the short x, long y. So we have 1/2 root 3 over 2, negative 1/2 root 3 over 2, 1/2 negative, negative, positive, negative. So this is the unit circle, and in the next video we'll talk about how to use it.